In this video, I want to have a look at solving trig integration problems by substitution. So we've looked at integration by substitution and we've looked at trig integration. So in this video, we're putting those two things together. So we're going to jump straight into our example, which asks us to evaluate the integral from 0 to 2 of the square root of 4 minus x squared dx using the substitution x equals 2 sine theta between minus pi on 2 and pi on 2. So the first thing I'm going to start by doing is evaluating what my new bounds will be. So we originally had x equals 0. So I'm going to use this substitution. So I'd have 0 equals 2 sine theta. And if I rearrange that, divide both sides by 2, I'd have sine theta is equal to 0. Now, we know that we're in this region here, that domain. So if I have a look in that domain, I should probably start here, we know that our sine graph looks like this, and pi on 2 is here. And if I mirror that, then I'd have minus pi on 2 down there as well. So in that domain, from pi on 2 to minus pi on 2, sine theta is going to be equal to 0 at 0. So we're going to have theta equals 0 still as our lower bound. And for our other one, when we had x is equal to 2, we're going to have 2 equals 2 sine theta. Now if I divide both sides by 2, I'd have sine theta is equal to 1. And again, if we look at our graph, we can see that that happens here, which is at pi on 2. So that means that my upper bound is going to be pi on 2. Now using this substitution, we know that x equals 2 sine theta. So there's two things we're going to do. One is we're going to differentiate that. So we'd have dx d theta. So differentiate x with respect to theta would give me 2 cos theta, which means that the dx in here, in that integral, can be replaced by a 2 cos theta d theta. So the other part of that is when we're going to substitute in this x squared here, the x can be replaced by this. So just off to the side, we can write down that x squared would be equal to this squared, which would be 4 sine squared theta. So you don't have to write that down, you can just do that when you substitute in, but to me that just helps that make a little bit more sense. Okay, so now I'm actually going to start with my integral. So I'm going to have the integral from 0 to 2 of the square root of 4 minus x squared dx. So that's going to be equal to the integral from 0 to pi on 2, using my new bounds, and I'm going to have the square root of 4 minus 4 sine squared theta. And then I had that dx there, but instead of dx, I'm going to have this whole 2 cos theta d theta. So times 2 cos theta d theta. Now if I simplify, not substitute, if I simplify this bit, I'm going to factorize out that 4. So I'm going to have 0 to pi on 2, the square root of 4 outside of 1 minus sine squared theta times 2 cos theta d theta. Now hopefully you can recognize this bit in the bracket is just going to be equal to cos squared theta. So I'm going to have my integral from 0 to pi on 2 times the square root of 4 cos squared theta times 2 cos theta d theta. Now because we have a 4 and a cos squared in there, we can just take the square root. So we're going to have 0 to pi on 2 of 2 cos theta, simplifying this bit, times 2 cos theta d theta. So if we multiply those together, and the 2 times 2, the 4 that we get from there, I'm going to pull that out the front. So I'm going to have 4 times the integral from 0 to pi on 2 of cos squared theta d theta. Now we know how that integrates from what we've looked at earlier. So I'm going to have my integral as 4 outside of a half theta plus a quarter sine 2 theta. Close my bracket and my square bracket, and that's going between pi on 2 and 0. So I'm going to expand this out and simplify it before I sub in. So that's going to give me 2 theta plus sine 2 theta between pi on 2 and 0. I'm going to get rid of all this over here and then keep going up here because I've run out of space. This is going up here now. So if I evaluate that, I'm going to sub in. So I'm going to have 2 times pi on 2 plus sine of 2 times pi on 2 minus, and then I'm going to have, if I substitute 0 in there, I'm going to have 0 plus, that looks like a 6, make it actually look like a 0, 0 plus sine of 0. Now that's just going to give me pi. If I have 2 pi on 2, that just simplifies to pi as well. And we know from our graph of sine that we had before that sine of pi is going to be 0. So this whole section is 0. Then we've got a 0, and we know that sine of 0 is 0 as well. So all of this just simplifies to pi. So that's having a look at one example of a problem that involves solving trig integration by substitution.